Well, okay, I have to admit that took me by surprise. I thought I had plenty of time. I was so wrapped up in the math that I overshot my time. So welcome to video part 2 on using inverse functions. I'll make this quick. So we were looking at how an inverse composed with a function doesn't necessarily mean they cancel each other out. And this is a prime example right here. We can see that we have the sine of negative 5 pi over 6. We know that if we're dealing with a sine function, or cosine or tangent, any regular trig function, we can go right to the unit circle. Negative 5 pi over 6, that's this shallow angle right here. It's 7 pi over 6, same thing. What is the inverse sine of that? Well, the sine of negative 5 pi over 6, we know is negative 1/2. That is a shallow angle in quadrant 2. I know the shallow angle quadrant 2 y value is negative 1/2. Now we're going to take the arc sine or the inverse sine. And now that we switch to an arc sine or an inverse sine, we're not going to use the unit circle. We need to be much more restrictive. We're going to go to our unit burrito. And in our unit burrito, the sine is negative. We know that's down here in quadrant 4. The sine is negative 1/2. Negative 1/2, that's a shallow angle in quadrant 4. That's right here. What is that quadrant 4 shallow angle? Well, we know that that's negative pi 6. Let's do just a couple more. Number 6. Number 6, ooh, this looks like a doozy. It's not. This time we're taking the sine of the inverse sine of negative radical 2 over 2. So we start out innermost set. Inverse sine. Well, anytime it's an inverse function, we're not going to use the entire unit circle. We're going to use one of our restricted values. And inverse sine is the unit taco. Now, inverse sine is negative. So that's going to be down here in quadrant 4. Where is the sine negative radical 2 over 2? Well, that would be at this bisector. So I know that this is really the sine of what? Well, negative pi 4ths. We've gone back to the sine function. So we look at the sine function. That's the unit circle. We look at negative pi 4ths. Negative pi 4ths is right here. Boom. What's the sine of that quadrant 4 bisector? Well, the sine's the y value. It would be negative radical 2 over 2. Well, it seems as though these inverse functions did cancel each other out there. Huh. I wonder if there's like a pattern or something to that. It's been intriguing me. Well, I will see. One last one. Let's do the cosine of the inverse cosine of pi. So here we go. We have the inverse cosine of pi. Inverse cosine, that's a very restricted. We're not going to use the unit circle. We're going to use the unit taco. So where is my little unit taco here? I seem to have lost it. There it is. There's my unit taco. The inverse cosine of pi. Well, let's see. Pi is a positive number. Where in the unit taco is the cosine a positive pi? Now remember, pi is like 3.14. So wait a minute. Where in the unit taco is the cosine 3.1? The biggest value the cosine can be is 1. This doesn't work. Not possible. This is undefined. This is not possible. You can't take the arc cosine of a number bigger than 1. And you've got to have the confidence in your problem solving to be able to say it's undefined or it's not possible. And this one, not possible. Now, we did some exercises, and then we did some problems. And there's one page left. Oh, it looks frightening. Let's jump in and see what this looks like, though. So here we go. Take a second, write this down. Okay, so we have to take the tangent of the arc cosine of 2/3. So now we're composing two trig functions. One is an inverse or an arc trig function. The other one, though, is a totally different trig function. Well, this seems really interesting. And this actually is much easier than you think it would be. I mean, after all, we're dealing with the arc cosine. That's supposed to be a square. a little wobbly here. Arc cosine we know is the unit taco. So I draw this unit taco. Now the arc cosine 2/3. That means basically what this is saying is this. What this is saying is there is some angle that produces a cosine value of 2/3. Now this is a positive 2/3. So basically we have an angle here. This is going to give us an angle, and I'm going to make this Greek letter alpha. A lot of times my kids call this the Jesus fish, but this is the Greek letter alpha. And I know that this angle alpha must be a quadrant 1 angle because this is positive. So somewhere in quadrant 1, there's got to be a right triangle. And if the cosine is 2/3, then there's an angle here. It's angle alpha somewhere in there. I don't know where it is. It's not going to show up. Okay. And the cosine is 2. Now remember, cosine is the adjacent over the hypotenuse. So I know, where is that little adjacent guy? Where are you? You here? Whoop, are you? Oh, it's right there. Right there. So I know that this side right here is 2 and the hypotenuse is 3. That's, after all, how we find the cosine of this angle alpha. So the cosine of alpha, and again, this is the angle alpha, is the ratio of the adjacent to the hypotenuse. And the Pythagorean theorem, a squared plus b squared equals c squared, will render this missing side, which I'm going to claim is the square root of 5. So I don't know what alpha is. I have absolutely no idea what angle gives me a cosine value of 2/3. 2/3 is not one of my unit circle measurements that I have memorized. I mean, I know cosine values of 1/2 and radical 3/2 and radical 2/2 and 0 and 1. I don't know 2/3. I don't care. It doesn't ask me what alpha is. This problem just simply becomes the tangent of alpha. And even though I don't know what alpha is, I can look at this triangle and I can tell you what the tangent of alpha is. The tangent of alpha is the ratio of the opposite to the adjacent. It's radical 5/2. That's your answer. So these problems that look like they're terribly evil, I mean, I did choose a rather evil-looking picture with Montgomery Burns, but they're really not that bad. Look, let's try another one. The sine of the inverse cosine of -3/5. Again, this looks terrible. But remember, an arc cosine or an inverse cosine simply gives us an angle. And so I know, dealing with the arc cosine, I know that I need to be in the unit taco. I know that we have a negative cosine, so this has got to be a quadrant 2 triangle. I know the cosine of alpha is -3/5. Now you'll notice I kept the negative with the x. That makes sense, right? Because my x value should be negative, and your hypotenuse is always positive. So I could find in this right triangle that has an angle alpha, and I don't know what alpha is, and quite frankly, I just don't care. I know that the cosine is -3/5. Now the Pythagorean theorem will yield this missing value here. I'll bet you most of you already figured it out. It's 4. And this just becomes a problem where I'm asking for the sine of alpha. I don't need to know what alpha is. Alpha is just an angle in this right triangle. I know all 3 sides of that right triangle. And I'm not asking for alpha. I'm asking for the sine, or the ratio of the opposite to hypotenuse. It's 4/5. Let's try another one. The cosine of the inverse tangent of -5/3. So inverse tangent, we know that is a unit burrito. So I'm going to go into my unit burrito here, whoops, my unit burrito. And I know that it's in quadrant 4 because I accidentally clicked the quadrant 4 triangle, but because it's negative. And I know that this basically, an inverse tangent, gives me some angle alpha. And I don't know what alpha is, but I really don't care. I know that the inverse tangent is negative 5/3. Well, tangent is the opposite over the adjacent. So now I've got to figure out where that negative goes. Does the negative go with the 5, the opposite of alpha? Or does it go with 3, the adjacent? Well, I think with a little bit of thought, you can figure out that the negative has to go with the opposite because the y value here is clearly negative. And we can use the Pythagorean theorem and find this missing side to be radical 34. Now again, the Pythagorean theorem, a squared plus b squared equals c squared, and we did some work. So this becomes simply the cosine of some angle alpha. I don't know what alpha is, but I don't care. I'm not asking for alpha, I'm asking for the cosine ratio of alpha. And remember, the cosine is the ratio of the the adjacent to the hypotenuse. So it's 3 over radical 34. But of course, we're not savages. We're not going to keep these radicals in the denominator. So clean that up, and there's your answer. So I know this was a pretty long video. You had to watch 2 videos. So you have a limited homework assignment tonight. Play around with it and see how you do, and we'll talk next time we meet.